Because we are a portfolio company of Vision Fund from SoftBank, I'm going to start with a dream, right? That's what Masa always starts with. So you dream. So robots will fit the world if we build the rails. There is an anecdote that I like to bring up because we are in Louvre and there's a lot of art around us. So when one of my senior technologists have seen this slide, there was a reaction, and I received an X message that was somebody posted and said, "We're pushing AI into a wrong direction," right? And the direction is, I want to create art and have the AI do my laundry. So I thought about that, and I said, well, then you need to buy an entry model and not the advanced model, and that will get you what you're looking for, right? But we have the technology, right, to be able to migrate or affect every person that we have today, right? What is missing is ability to pour the knowledge worker into the physical world, right? And we're going to hear a lot of interesting people talking about robotics, inference, and all of the other things that comes with it. But AI is already redefining every industry. It's already here, right? It's a fact. There is nothing that we need to think about. It will affect every single industry as we are going forward. So there is a myth. And the myth is, oh my God, I'm going to lose my job, right? It will destroy jobs. Same myth happened when we released steam, electricity, when we released computer, internet. All of those things, took prosperity up a notch, right? And had a long tail that resulted in the global prosperity and titanium shift into re-educating our workforce. So how do we reach the abundance of what we need? Number one, energy. There is no energy. There's nothing we can do. We cannot dream. So we need to produce every possible micron that we can gather, right? I was driving just recently in a Dutch countryside and I saw those windmills. Anything is on the table, right? Anything that can produce a micron is going to require to power our future. The next thing is GPU. Now, think about it. Billions of intelligent devices pushing metrics data to the cloud, continuously generating petabytes of data, all right? And that's the purpose of it, is for fine-tuning and training, right? Some of the training, fine-tuning will happen locally, but for the most part, it will go to the clouds. So how much more GPU power we are going to need? So GPU is another element that we require for us to move into the physical world. Open source models, right? How do we balance billions of invested into the commercial labs that truly deserve their rank in the status? And how do we make sure that regulatory handcuffs are not there? I don't know how many of you have seen the big, beautiful bill that was signed in the States, right? One of the things in there is that every state, and there are lots of them, can mandate how regulatory deals with AI, right? The big AI labs have written all of the regulatory policy. So that would kind of prevent the smaller player that don't have billions of dollars in financing to be able to compete. Until I thought about it, there's going to be some smart couple of guys and gals who's going to say, I'm going to build a model that's going to decouple all of the regulatory state by state and be able to help younger companies to succeed and compete against the well-funded multi-billion-dollar entities. The next thing is infrastructure, right? So we need our ability to orchestrate just like we have today, right? In the simple web scale cloud. Robust pipelines, CI/CD, right? And most importantly, and there was a conversation here, we don't have enough AI ML engineers, right? I mean, somebody said 1,000. Maybe there's more, maybe there's less, but there's not enough of them, right? So we need to make sure that we actually produce more of that future. I was reading an article just recently where people are saying, we don't need engineers, it will code itself. But who's going to create the next generation and the next generation? It's us, right? So we do need engineers. So how do we keep the Rails abundance, right? Rethink how we create electrons. Without electrons, nothing will scale. Infrastructure on a planetary scale, like the project Stargate, right? Everybody heard about the Stargate, right? And purpose-built GPU-intensive platforms. This was a conversation here by a few guys, but there are many purposely built GPUs, data centers. Democratizing AI with open weight models, right? And easy, affordable inference. That's how we're going to keep the abundance intact. So I asked one of my technical teams to bring a very technical slide to show how, for example, CAS deals with inference, right? And then took that slide and I created a more easily digestible material. So you have a supply side and demand side. Supply side is your purposely built GPU data centers, right? That's your supply side. Demand side is the application requiring those types of GPUs. The inference that I am discussing is to invisibly serve that GPU for that application, never leave the environment it is in. That's the magic here, right? So your application requires a set of GPUs. The platform, like us, inference, would go out and be able to attain affordable, that's the key, affordable GPUs for that particular moment in time that application needs, right? Now, zero friction, right? Cloud agnostic, and as I mentioned, invisible. Now, it must be secured, right? There must be trust where the models and the customer data remain secure within private control environment. That is a must, right? And that's what makes a fantastic distributed GPU architecture, where it can serve a GPU when it needs it at the most efficient cost possible. And I'm not going to bore you, right? So I'm going to leave some time for the next folks. But in the next 10 years, the Rails, right? And that's not the Rails from Eurostar I took today, but the Rails that we just described will define and build who will benefit and who will be left behind. So let's make the open, fast, and fair for all. Thank you very much.